Madam, good morning. Good madam.
Sir, good morning, sir.
Good morning, madam. Audible இருக்குங்களா?
It's audible.
Okay, madam. Thank you.
Sir, principal, sir.
Madam, பேசிட்டேன் வந்துருவார் லைன்ல வந்துருவார் நினைக்கிறேன்.
Okay, sir. Principal வந்தோனே ஸ்டார்ட் பண்ணிரலாம், sir.
Okay, madam. Okay. Sir, good morning, sir. Sir, audible இருக்குங்களா?
Sir, நான் பேசுறது கேக்குதா?
கேக்குதுங்க சார், கிளியரா இருக்கு.
It's audible for me also.
Okay, sir. Thank you, sir. Thank you.
Sir, good morning, sir.
Sir, good morning. Yes, madam. You can start.
Shakti, you can start.
Try not to become a person of success, but rather try to become a person of value. A very good morning to one and all gathered here for the AICTE sponsored 2-week faculty development program on the very interesting topic, cutting edge trends in deep learning approaches. We have zeroed in on new and engaging topic and speaker to get your upcoming days vibrant and useful for a week of 2. We hope you enjoy the sessions as much as we enjoy organizing them for you. I welcome you all once again. Without any further ado, let's get into the event. A simple grateful thought turned towards heaven becomes the most effective prayer. I now invite Ms. Vidya to lead us in prayer.
எனக்கு வேண்டும் வரங்களை இசைப்பேன் கேளாய் கணபதி, மனதில் சலனமில்லாமல் மதியில் இருளே தோன்றாமல் நினைக்கும் பொழுது நின் மௌன நிலை வந்திட நீ செயல் வேண்டும். கணக்கும் செல்வம் 100 வயது இவையும் தர நீ கடவாயே. எனக்கு வேண்டும் வரங்களை இசைப்பேன் கேளாய் கணபதி, இசைப்பேன் கேளாய் கணபதி.
Thank you, Vidya. Small cheers and great welcome make a merry feast. I now invite Dr. R. Tamilselvan, Professor and Head, Department of Computer Applications, to welcome the gathering.
Respected Principal of our college, Dr. V. Balusamy sir. Resource person for the first session, Mr. Amit Misra, International Corporate Trainer and Data Science Consultant, AI Council, New Delhi. Faculty coordinator of this faculty development program, Dr. Shanti and Dr. Paingudi from the Department of Computer Applications, and other participants from Kongu Engineering College and other colleges, and my dear student volunteer, a very pleasant good morning to all of you, and I'm really very happy to welcome you all for this faculty development program sponsored by All India Council of Technical Education, New Delhi. First of all, I welcome the President of the today's inaugural function, Dr. V. Balusamy sir, Principal, Kongu Engineering College. I welcome you, sir. Next, I welcome the resource person of the morning session, Mr. Amit Misra, and he is an international corporate trainer and is a specialist in data science consultant, and from New Delhi. I welcome you, sir. Next, I welcome the faculty coordinator of the faculty development program, Dr. Shanti and Paingudi. Welcome you both, madam. And finally, and welcome all the participants from our college and other colleges to participate in this function. And I request all of you and all the participants to make use of this program to enhance the knowledge in deep learning approaches. And it is a great opportunity to all of you because we are all going to attend the faculty development program through online. So wherever we are there, and we have to sit over there comfortably, and we have to listen the topics in a very comfortable manner. So that I request all of you to make use of this program and get grand success. So with these few words, once again, I welcome you all for this FDP program. So thank you, and all of you enjoy this program. Thank you. Thank you so much.
Thank you, sir, for your very warm words of welcome. If you can speak, you can influence. If you can influence, you can change lives. May I now request Dr. S. Shanti, Associate Professor, Department of Computer Applications, Kongu Engineering College, to give a brief detail about the AICTE sponsored 2-week faculty development program on cutting edge trends in deep learning approaches.
Good morning to all. It's a great pleasure to be here for sharing a few words about this AICTE sponsored 2-week FDP on cutting edge trends in deep learning approaches. We received the grant from AICTE to organize this FDP in 2 phases. Today we are in first phase. We received 500 plus registrations from faculty, research scholars, industry persons and PG scholars from diverse parts of India, and we selected 100 participants from different colleges, universities and industries to attend this program. This FDP is designed with the state-of-the-art concepts of artificial intelligence, machine learning and deep learning technology that comprises of theory as well as hands-on sessions. Half of the course is designed for theory, use case demonstrations and research-oriented discussions, which will be helpful in understanding the process, and the remaining 50% of the course for practical implementations. The session of this FDP is organized with different resource persons who are having rich experience in these areas. I hope this program will fulfill your expectations and give pleasant learning experiences with different dimensions for further exploration. We look forward to seeing your benign presence with active participation and support to make this FDP a huge success. I like to conclude this by saying my favorite quote: "Tell me and I forget, teach me and I remember, involve me and I learn," by Benjamin Franklin. Have a joyful learning indeed. Thank you, one and all. Have a nice week.
Thank you, ma'am, for the brief introduction. The one quality that can be developed by studious reflection and practice is the leadership of men. May I now invite one such astounding leader, Dr. V. Baluswamy, Principal, Kongu Engineering College, to felicitate the gathering.
Thank you, Dr. Tamilnadu, coordinators, Dr. Pangudi, resource persons, Sri Amit Mishra, Sri Bipal Kumar, and Madam Imaya Bharati, and my faculty colleagues in KEC, Dr. Tamil Silvi, Dr. Tangarajan, Dr. Radhalakshmi, Dr. Nadia, and all colleagues, experts, participants of this AICTE-sponsored effort from KEC and from other institutions. I'm very happy that an FDP supported by AICTE has been organized in a field that's fast developing. We have heard about artificial intelligence, and now many fields in different like agriculture, medicine, military science, legal education, education. Everyone is talking about data science, and everyone has started data science analytics to their fields. And now we are enjoying the benefits of this application of data science, and now we find many analytic techniques have emerged. And this which has emerged few years now out of this and this subset of machine learning technique with application of artificial neural network. In a way, to me, I understand this automation of this machine learning process, which has evolved from this data science. I can only think of various fields of application. In fact, a layman like me, when I look at a baby, how baby behaves, seeing different objects around it, like identifying it and identify as it perceives. So I enjoy how the baby behaves. But experts like you, experts like Amit Mishra, Bibal Kumar, will look at the baby in a different way. Like how this neural network functions, recognition of object. So all these techniques and at today's perspective, we have complex problems in different fields. Like right now, everyone is struggling to find some way of controlling this corona. So I wonder whether this deep learning technique can help in some methods of controlling this. Use this deep learning technique medicines, pharmacy, evolving method, coming out new solutions diseases, and for the manipulation of techniques and pharmaceutical problems, then finding ways in security perspectives, helping the armed forces, helping our agriculturists field to find out some even in people for like us, sometimes we struggle to find some solutions in higher educations, in teaching techniques, evolution techniques. So I'm sure this new techniques, deep learning approaches, deep learning technology will help us in finding solutions all these problems. Of course, techniques can also be used as you would have in news, scientists are engaging very famous data scientists for their own agenda, like manipulation of election results. And sometimes we are seeing that experts can use this technique by certain maybe to put up the case to particular judges for long time. Stock market people have used this technique to predict the price, to predict the price. Commerce people have used it to predict the commercial prices and manipulate overall understanding of this application. As technologists, we should use this technique quite effectively for various fields. This short-term FDP, wherein about 100 participants are going to benefit, I'm sure will be an eye-opener for the researchers to come out with new techniques and use it effectively for various applications. I wish this FDP support continues. And first of all, let me thank Kongu for technical education granted to conduct this FDP for about 100 participants. I wish this FDP a great success. Thank you all.
Thank you, sir, for your very vibrant and enthusiastic words of wisdom. I now invite Mr. Gaurav Kumar to felicitate the resource person of the day, Mr. Amit Mishra, International Corporate Trainer and Data Science Consultant, AI Council, Delhi.
Good morning, all. I'm Gaurav Kumar from third year MCA. Our resource person for today's session is going to be Mr. Amit Mishra. He has expertise in the field of big data with Hadoop and Spark framework, artificial intelligence and machine learning, data science using Python, R programming, cloud computing with Amazon Web Services, website development and hosting on Cloud AWS, data analytics using Azure, Spark machine learning using SciPark for more than 7 years. He has worked as research engineer and project lead at Times World. From November 2015 to present, he has been working as corporate trainer and data scientist at AI Council, New Delhi. He has expertise in delivering Oracle University program and Cloudera certification training programs. He is a Hitachi Ventra certified trained for data science and Capgemini trainer test qualified for AI and machine learning with 90% of test score. He has delivered more than 300 corporate training programs, faculty development programs, workshop, and seminar on various modules at international and pan-India level, including corporates and reputed technical universities. He has implemented a system for Amazon customer review. He has worked on implementation of self-driving car using deep learning. He has implemented image recognition and recommendation for a leading IT company for their product name recognition. We welcome you all. We welcome you, sir.
Thank you so much, everyone, for your warm welcome.
Thank you, Gaurav. A leader is the one who knows the way, goes the way, and shows the way. The essence of leadership is that you have to have a vision. True to this, our resource person, Mr. Amit Mishra, is here to take over the dais and all our hearts with him. I hope that each one of us would enjoy and benefit from the session. Sir, the mic is all yours now. Thank you.
Thank you so much, everyone. First of all, good morning to all the participants. I, Amit Mishra, on behalf of AI Council Delhi, would like to pay my regards and thanks to the KEC management, principal sir and vice principal ma'am, and all the coordinators who are behind this program. And also, I welcome all the dear participants for registering themselves and showing their keen interest towards this training program of deep learning. Deep learning is really one of the, it does not require any introduction anymore. It's one of the cutting edge technology right now with various wide applications. And we at AI Council focus on delivering the best with not only just with the theory, but also the kind of an application that will be useful as a faculty or as a student or as a research scholar. We believe that the theory is equally important as the applications are. Hence, our courses are designed and we try to deliver it in a balanced manner. I wish that this program will be very beneficial for you. I'll keep the things very short. Thank you all the management behind this training program. Thank you so much. And now I will be starting off my session. As per the schedule, the first topic of the day will be about machine learning and AI introduction. I hope my screen is visible to you.
Hello, sir.
Hello,
Mr.
ma'am.
Sir, your voice is too low, sir.
Hello, everyone.
Sir, one
Ma'am,
noise
is
is
it
coming,
fine
sir.
now?
Sir, one
Able to hear
additional
me now,
noise is
ma'am?
coming, sir. Noise
Fine
is
now?
coming, sir.
Able to hear me now, ma'am?
Sir, one additional noise is coming, sir.
Ma'am, I guess the voice is fine now.
Now it's fine, sir.
Okay, ma'am. All right. So I hope everything looks good now. I will be starting off with the topic of introduction to machine learning, artificial intelligence, and deep learning. Yes, ma'am. Do you able to see this screen? I guess.
Yes, sir. It's visible, sir.
Okay. Thank you. So, we'll be starting off with our introduction part of machine learning and AI. Let's begin. So I'll start with the basic brief about what is machine learning with the question. And the question is, let's say I have taken a 40 person and this 40 person, and I'll ask this person about what is this image. What is this image? So if I talk about this image, the person will respond me, it's a pizza. The question arises how this person knows about how this person will able to recognize whether it is a pizza and not a burger. It's inside its head which is providing it a knowledge which he has, which this foodie person has might have gained by seeing this image and then recognizing it back whenever the question has been asked, what is this kind of an image? Without any hesitation, by using its previous knowledge, this foodie person will say that it's a pizza. All right. How this is relevant to machine learning? So it's machine learning also uses the previous knowledge gained by the data or the various sources of the data and utilizing that data and make the decisions. The decisions will be for the futuristic values, or maybe the data, or maybe for the past data. Here the knowledge part is important when it comes to machine learning, and knowledge will be gained by the data. So indirectly it's all about the analyzing the data, gaining the knowledge, and then making decisions by its own. Just like here, this foodie person able to recognize this image is a pizza, not a burger, by using its previous knowledge. That's why I have used a foodie person and not a person. If a person who is having a knowledge about all these food, that person only will able to recognize it better. How this process works of gaining the knowledge? So it's a two-step process. Step number one called as training. Step number two is called as testing. In the training phase, just like you all, the dear participants, you all are getting trained from tomorrow onwards in the topic of machine learning, AI, and deep learning. So in the training phase, suppose this is an empty human brain of yours, and or of a child, or of an untrained brain. In an untrained brain, the knowledge will be empty right now because there is no data has been fed. So let's feed some data. In the training phase, you need to feed the input as well as the relevant output. Both needs to be fed inside it. The input data is 2 plus 2, the output value is 4. Suppose 20 plus 20. This is also an input. Output is 40. And so on, you need to keep on feeding a lot of inputs and a lot of outputs. The important thing is more is the data, better will be the training. So you need to feed the input as well as you need to feed the output. You need to feed the input values as well as the relevant output. And hence, your untrained brain will convert itself into a trained brain, as you can see on the screen. The trained brain will have the logic, which you can say has developed the knowledge. Utilizing this logic value or the knowledge, what you will do is you will be utilizing the logic, and if the logic would have been successful, that means indirectly I will say that the training was accurately done then by when you will be providing a complete new input, let's say 20 plus 30, the output will be 15 in this case. All right, so this is your two-step process of machine learning, deep learning, whatever you want to say it like this. Either machine learning that also has the same logic of taking an untrained logical function or mathematical function, feeding them with the input as well as the relevant output, resulting into a good trained brain, a good trained brain which will able to make the correct predictions. Here in the testing phase, you will be feeding the input data as well as, and you will be expecting the correct output from the knowledge gained. Ma'am, somebody's mic is on. Just somebody's mic is on. All right, so this is how your things will be working. Let's proceed ahead. Now, we talked enough about the human behavior, about learning. Let's talk about how this can be implemented to a machine. When it comes to human behavior, we have a human brain, which has a natural build-up phenomena to gain the knowledge whenever the source of the knowledge is available. The knowledge can be in the positive as well as negative. We learn every day and we try to improve every day from the various sources of audio, video, books, and blogs, reading, etc. But with machine, the things are quite different. It does not have any logical brain or natural phenomena of learning. We need to give some artificial intelligence to make my machine function and think like and behave like a human being. Suppose the same example which I took in the start of the session, that was about classifying, like recognizing what is this image. So usually for a human being, it is a very easy task, but for a machine which works only on logic, maybe it will be a tough task. So let's talk about here how does we can achieve the same thing with the help of a naive machine. Naive here means it's a complete new machine which does not have any, you can say, knowledge, which is completely new to this particular topic. Just like most of the participants would be naive about the deep learning topic. So how does we try to provide the knowledge to the machine? So replacing this human brain with a mathematical function or a statistical function will be a good move. This will be either this f of x denotes a logical function, a logical mathematical function, or a statistical function. You will be providing again the input provided by x and the old input data and the relevant old output. We have provided both. Why I am using old? Because we require some old data, some historical data that will be required, so that this f of x can learn the hidden parameters Okay. In short, what we are trying to do is we are trying to feed the inputs and its relevant output that are available in the form of a data to us, and using this mathematical function we'll be providing the old input as well as the old output, so that this f of x will gain the knowledge and will able to make the decisions. This f of x here is called as the algorithm, which will be nothing but a mathematical function or a statistical function. Let's talk about here the input data x. Let's talk about here that in the second phase we will be feeding the completely new input data, just like we did in the previous case, and this will be your predicted output. We generally denote the predicted output with y hat. Okay, we expect a good prediction once the training phase was over. This was your training part where you provided both the things, the input as well as its relevant output. In the testing phase, you are just providing the input data that will use the previous knowledge it will use the previous knowledge and will result into a predicted output which is given by y hat. Let's proceed ahead and let's try to define the machine learning. That was about all the brief. Let's talk about what is machine learning with the definition. Machine learning is a subfield of, very interestingly, it is a subset to artificial intelligence. What is artificial intelligence? We will discuss about it, and we'll also discuss about how artificial intelligence is different from the approach of machine learning. First, let's try to understand what is exactly machine learning is. So machine learning is subset of AI or subfield of artificial intelligence that involve the development of self-learning algorithms. These self-learning algorithms are given by f of x. This helps in gaining the knowledge from the data in order to make predictions. Now, the overall phenomena here is all about gaining the knowledge, which will be dependent upon the type of the data that you are providing, which will result into making a good prediction for the futuristic data that will be provided by the user or by the reliable source from wherever the knowledge has been gained. For example, I want to automate a process of predicting the cost of the house by providing a lot of features like area, features like location, features like crime rate, features like distance, like whether it is a sea facing or not. Depending upon these particular features, I have some past data relevant to us from any particular sources for a particular location, and that has been given by the various cost. So depending upon the area, location, number of bedrooms, number of bathrooms could be also one of the could also be the parameters here. So depending upon all these parameters, which will be treated as your x values, say x1, x2, x3, x4, and cost is given by y. What you can do is you can provide these x1, x2, x3, and x4 called as your various parameters, or from the source of the data, which you will be mapping to the cost of the house. This data must be available to you. Without the presence of the data, you can't perform any machine learning job. It's dependent upon the data and the gain of the knowledge by the help of the algorithm, or better said, self-learning algorithms. The prediction will be made by the help of the data. Instead of requiring the humans to manually derive the rules and build the model for the analysis of the large amount of the data, machine learning offers a more efficient and alternative for capturing the data, for capturing the knowledge in the data to gradually improve the performance of the predicted model and make a data-driven decisions. You can see everything here is emphasizing on the kind of a data and making this process an automated process of learning the knowledge from the data, and then the efficiency of predictions should be it will be trying to improve as the source of the data will keep on increasing. The performance of the prediction will keep on increasing. The accuracy of the prediction will be keep on increasing. It's a data-driven decision. It will make the data-driven decisions. This is it for your machine learning, where it's everything dependent upon very important topics, and that is depending upon the data. If I'll say in very short, then machine learning tries to mimic data. Machine learning mimics the data to gain the knowledge. All right. Any other okay, I'll come back to that part of asking you the question. After, let me first take the another topic, which is called as AI, and then I'll give you the chance, all the participants, to ask you doubts and questions. So first of all, let's talk about what is artificial intelligence and how it is different from the machine learning. The artificial approach is just like a human brain. What is the approach of a human brain? First, let's define what is AI. So AI is a branch of a computer science dedicated to create intelligent machine that can work and react like a human brain. If I said the word called as machine learning mimics the data, so for AI, I will say AI mimic human brain. This does not talk about gaining the knowledge from the data or self-learning algorithms. The decision is data-driven decision. It does not even talk about improving its performances of making prediction, because AI is not meant for all these purposes. The AI purpose is entirely different. And what kind of a things your AI do? Let's talk about it one by one. I will first say what is artificial intelligence and how does it exist. So artificial intelligence in the Venn diagram form, if you will observe, it's the outer parameter. Your machine learning is the subset to it, so it will be the inner, it will be inside it, and the deep learning is even smaller. Deep learning is basically subset to machine learning. Artificial intelligence is a program that can sense, reason, act, and adapt, whereas machine learning are the algorithms whose performances improve as they are exposed to more data over the time. Let's try to differentiate here some of the key differences between AI and machine learning. Artificial intelligence, as I said, I will repeat once again that AI will mimic artificial intelligence will mimic the human brain, to make decisions. Artificial intelligence artificial intelligence very important word coming up. Is not required to be pre-trained to gain knowledge. AI is self-training models, and it takes okay, let me correct, and it has self decision making ability. AI is self training model, and it has got the self decision making ability just like the human brain. All right, just let's talk about once again here. Let's have some few points about the machine learning as well. So as I said, machine learning mimics the data. Machine learning required to be trained and exposed to more and more data. No self decision making. For the AI, I said that there is no requirement of pre-training the model. Whereas for machine learning, your training is important. Otherwise, it will not able to make any decisions. AI is self-training model and it has got self-decision making ability as well, just like the human brain. Here, there is no self-decision making ability is there. Okay, let's talk about few more points. Machine learning solves with, okay, machine learning approach is to make prediction with good performance. The second point, machine AI approach is to solve a given problem. All right, I hope the differences are a bit clear to all of you. The approach of AI is to solve for the problems statements. Let me take some example to make this thing a bit more clear. Is this thing is clear? Let me just check. Yeah, able to see this white screen board? If you can just respond onto the chat window. Okay, wait a second. Now, can you see this white screen? I hope this will be visible to you now. All right.
The screen is visible, sir.
Okay. So let's talk about here that how we can differentiate the AI and machine learning part. Somebody's mic is on. All right, so if you will see here, I was talking about, let's take some examples of an AI. So the AI approach will be about to solve for a given problem. Let's say There's a point A, there is a point B, and I want to create an AI-based vacuum cleaner. An AI-based vacuum cleaner, and its work is to clean the floor between the location A and location B. What will be the approach of this AI-based vacuum cleaner is that it will be using the AI agent. AI agent here is just like your algorithms, and here these agent does not require any pre-training. First of all, that's the benefit. You don't need the data or past data. If you are not having some past experiences, it's really okay. The artificial intelligence has the ability to self gain the self improve, self learning, and self decision making ability. I will write this word: artificial intelligence has the ability to solve any given problem for success. And for which it does not require any data. Okay, some past data is not required. It will only learn it during the like course, whenever you are trying to solve for the given problem, and it will try to solve to so for the given problem it will be trying to solve and then gaining the knowledge. It will start, this is your AI agent, which will start from the source 1 A, and then it will go to the destination B. The conditions will be there. For example, if dirt is true, it means if dirt is present. If dirt is present, or what is the status of dirt is. So if dirt is there at A, it will try to clean the floor first here. As soon as the cleaning is done, the dirt status will become false. Then it will go to the destination B. It will move to the destination B. Again, it will check the status of the dirt here, and it will keep on moving between A to B, A to B. If dirt is nowhere present, then it will be stopped here. Okay, how it will be gaining, how it will check if the dirt is present or not? With the help of sensors. So the source of the data is obviously required here as well, so that it can sense, the machine can sense if the dirt is present or not. In both the destinations between A and B, the sensors will be present, and the sensor will send the message to the AI agent, to the vacuum cleaner, and the AI agent will respond to it, and correspondingly it will try to clean the floor. In AI, the approach is to solve for the given problem. Here the problem is to clean the floor automatically. So similarly, there could be many other different problems, and the goal will remain as it is. The goal is to solve for the given problem, and the problem was here to clean the floor. Similarly, let's take an example of Google Map. In the Google Map, let's say my problem statement for which, or let's say the better approach will be about a chess game. In the chess game, you know what is the problem statement? Problem is to create an AI based chess game So to win the game, okay, so maybe at start of the game, the AI agent will not be a perfect one. Maybe it will result into a losing side. But with every move it will be making, which will be say is resulting into winning the game, those moves will be stored in the memory. So sometimes not only just now here in this case, your agent will be something which will react automatically to the sensors reading. There is no memory required here, but here in this case, your AI agent will be not only just using the current input status, but also it will be using the past memory. Past memory about how AI, or you can say the good moves. In short, all the good moves will be there. Good moves that resulted into getting any opponent's player of the chessboard game, like knight or pawn or whatever, or queen itself, or king itself, winning the game in the end. So all those good moves will be stored as in memory, and your AI agent will be keep, obviously the source of the data will be the opponent's moves, and those will be keep on feeding inside your AI agent. Plus it will utilize the past memory to make the new moves. All right, so that's how you can differentiate between the machine learning approaches and the AI approach. Let's talk about one more thing here, the machine learning part. Let's talk about the machine learning. What kind of a problem statements? See, all those problems which you see right now are most of them are dependent upon machine learning. Why? Machine learning gives prediction with accuracy. Let's talk about you want to create a, you want to solve for a given medical data. Okay, let's say that you are having some images. Just a minute. Let's say you are having an image of from the medical source, an MRI image I have taken. Okay, this is your MRI image. Using this MRI data, I want to create an approach which will able to recognize where exactly the tumor is. Or you can say, I want to capture that particular area where is the where is exactly the uh, tumor is, what's the size of it. Or you can say, I want to differentiate whether the person is having a tumor or not. So this is the kind of a problem statement that requires efficiency, that requires the accuracy of prediction. Otherwise, the reliability factor will be always there in AI. In AI, it does not talks about that this much accuracy was about my winning the game. This was my accuracy. No, it does not talk about it. It talk about only about winning the game or losing the game, or it's all about starting from a source and reaching to the destination. It does not talk about the accuracy terms, like how many times, what was the accuracy of predictions. When it comes to these type of problem statement, scanning the images and then giving you the accuracy, okay, this is the percentage of the accuracy that this model will, all the algorithm will able to make the decision about whether the person is having a tumor or not. When it comes to the prediction with accuracy, we rely on machine learning. All right, this was one of the problem. Similarly, there are many other applications that is there. Let's say the filters. Instagram filters. Let's say removing the noise from the image. Let's say you are having a noisy image and you want to remove all those. Let's say you are having a noisy images of human faces and you want to eliminate those noises. So that could be one of the example. The face ID. Right now in the COVID, not everyone will be interested in using the biometrics. How about face ID biometrics? Machine learning helps in there. Everyday classifying emails into spam or not a spam. If you all are familiar with the Gmail, there are categories of emails which goes into the inbox and there are emails which goes into the spam. So how they are identifying it automatically, how the machine identifies that this email looks like a spam type or the other email does not look like, or does not look like a spam email, and it will be feed it into the inbox. So whether to fill it, whether to categorize it or classify it as a spam or not a spam. Similarly, you can do it not only just for email but also for the calls. Right now you see that the call that comes from the credit card or banking, uh, they automatically appears as a spam calls, and you can easily identify that this is a call from any particular customer care center that are offering you some free lifetime free credit card, etc. All right, so daily users things are these type of example which you see in your in around. Those are your machine learning based examples, most of them. I hope these examples would have been good for you. Now over to you all. You can ask your questions one by one. You can, to ask the question, you can use mic or you can use the chat window. Any questions anybody having? Please kindly ask your doubts and questions with the help of the chat window.
Sir,
Yes.
sir, for Face ID and biometrics, sir, it is necessary to use machine learning, sir. It can be done with normal applications also.
No. Not every day the same person will look like as it is. So you require the is to be done by the machine learning approaches. By the way, what is the alternative? Like you're saying it can be done without it. How it can be done without it? You can also take an example of the screen locks. Those are also using, like in most of the smartphones right now, they are giving the Face ID thing. The screen lock, that could be one of the examples. Any other question? Okay, I will treat that. There are no questions here. So I will be moving ahead now. Is it fine? I hope the differences and the things are quite clear to you. The next part that comes in my mind is deep learning. So let's talk about the deep learning approaches. So where exactly you will be requiring the deep learning approach? I hope the approach of AI is clear to you. Where exactly you require AI? AI is used to solve the problem. You have a given problem, you will be providing it. You have no data availability for that particularly. It won't be a data based learning in the AI. It will be dependent upon the input that has been given by from the environment, and obviously the source of the data must be there. Let's say in this case the source of the data was the opponent move. Okay, and here the source of the data is the sensor. So similarly, but in ML it is all about you are having the data, some past data. Okay, and using those data you will try to do some to trying to solve the given problems. Let's say uh, a person like you are having some diabetes data. Okay, various particular things are there. Diabetes, classifying the person, classifying if person is diabetic or not. Classifying the images, or let's say stock price prediction, cost of house prediction, etc. All right, let's move ahead. This was all about some examples that requires in all these sections you require the data, you require the images, otherwise you won't able to solve for the problem statement. Okay, next is deep learning. Next is deep learning. In the deep learning, and how it is different from the machine learning approaches. First of all, deep learning extract the features or important features for making correct predictions. Deep learning is to extract the important features for making very good prediction rate with a very huge prediction rate. In the DL approach or deep learning approach, the huge prediction is the most important key. Let's say I'll come back to the same problem statement when it comes to identifying closely that your MRI scan is there for two person. One is your tumor person, the other one is without the tumor. So if you are having the person, like you are having the MRI scan data of tumor and not tumor, then with the help of the deep learning, you can classify both of these images. Deep learning extracts the important image features, all right, and with the help of it, it will able to apply. Uh, One important thing about the deep learning is deep learning solves the given problem using neural network. Neural network is a kind of an algorithm that you will be definitely studying in the deep. Right now, you understand just that this is one of the algorithm that is available. Using the neural network of human brain. Our human brain is having a lot of neurons in it, and the cluster of neuron is called as neural network. The approach of the deep learning is exactly like utilizing those neural network of the human brain to solve for the given problem statement. Okay, obviously in human brain we are having the natural neural network. Here the approach will be about mimicking solving and making prediction using artificial neural network. In short, it is called as ANN. No matter what type of problem statement you are talking about, deep learning approach will be all about trying to solve it using the human brain's neural network approach in an artificial way, which will be like say artificial neural network, or in short, it is called as an ANN. Let's say you're having some problem statements here. I'll take two fruit images. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Let's say we are having an apple, and I want to teach my machine that identify the features of it which makes it as an apple. Features means, let's talk in short minute. This is what the humans see. But when it comes to computers or machine, there is not identified as an image of apple, but rather it is identifying itself as an matrix of RGB. Image number one, matrix number one. RGB. So there are three, like this is what you see and what computer sees it. So it's all about the RGB matrix. When it comes to the machine learning approaches, it's not like that machine learning can't solve these type of problem statements of identifying the images. It can solve it, but the major thing is it's all about the accuracy and it's all about the approach. In machine learning approaches, you need to do the feature extraction as an external process. When I say feature extraction, I mean extracting out the important values from the RGB matrix that has been identified. Each matrix value will be filled with 0 to 255. Each matrix box will be filled with any value between 0 to 255, of which your feature will be extracted. Feature extraction means after the feature extraction is done, you will be applying the algorithm. Let's say f of x. This is your algorithm number one. And it will make the predictions. Extract the features provided into the f of x and make predictions. All right. Let's say the accuracy rate of making the prediction comes out to be near about 75%. But you are not happy with it. You want 100% accuracy. Or you say you want at least 99.5% accuracy. What's the solution? So people, when they have started applying the machine learning, they also improved the things over the neural network, and they recognize that if the same problem statement, if I'll be trying to solve with the machine learning approach, in spite of machine learning approach, we'll try to do it with the deep learning approaches, I'll get a very high accuracy. Plus, we don't have to do the feature extraction as an external process. We don't have to do it. But rather the feature extraction will be done as an internal process. What will be the approach? Let's say this is your x value. You'll feed f of x. This f of x will basically be transforming your current input data. Let's say the output which comes out from here is your x dash. This x dash will be again feeded into the next, which will give you the x double dash now. X triple dash. So all will give you, this will be extracted and it will give you the final y hat. This is about make predictions. As you know that the deep learning is your subset to machine learning. This will keep on extracting the things one by one. And finally, you are getting the y. Accuracy rate will be 99%. All right. I hope these differences are clear to you. Now over to you all. Ask your doubts and questions. All the participants are requested to ask you doubts. Any queries, any questions?
No, sir.
Okay. Fine. So I will be now proceeding towards, that was all about your deep learning approaches and the machine learning approaches and their differences. The deep learning takes like what kind of a problem statement you will be doing. So again, face recognition will be one of the key part because it requires a very high accuracy. So face recognition, then medical image classification, any image classification will be really good. Shares prediction, noisy image, noise from the image, reduction in it, then dimensionality reduction. Okay, let's not talk about the dimensionality reduction. Let's say some of the more important thing, noise from the images will be reduced. You can make prediction of time series data like shares or COVID-19 prediction. Very important is about text prediction. Example is Gmail. In the Gmail, whenever you type any mail right now, you will see that it gives you suggestions. So those suggestions are also the example of your AI plus deep learning approaches that analyzes the text data, and then it identifies that what kind of a word will be suitable to frame the better sentence. So those text predictions or text, rather say text suggestions uh, in your Google Gmail, that could be one of the things. Sentiment analysis, of any product review. Let's say you are having a product, and that product has got a lot of comments on it, and on that e-commerce website you want to analyze those products, whether it is a positive feedback or a negative feedback. That is called as sentiment. Sentiment means positive, neutral, or negative. So these are the things, these are the sentiments which are there, and we uses them to apply and analyze your various images, etc. Okay, we are done here. Our basics are over. If you have any queries and questions, kindly ask it. Why DL is mostly working on image data, sir? Not exactly. We apply it onto the images only. Images are considered to be more complex as compared to your normal data sets. That's why we apply deep learning to the most complex data sets. That's why I took the example of images. But as you can see, this is your ML approach. Completely myth that for images you don't apply any other, like you can't solve it using machine learning. You can solve it, but your prediction will be not as accurate as that are possible in deep learning. In deep learning, you can expect a very huge accuracy. Accuracy is important in this. Accuracy gives you a confidence that you can also, sometimes this accuracy is called as confidence. Confidence means how much accurate your values are. When you're making the predictions, if a person is getting identified, so it can give you the strength, like this person is near about 98%, that looks like, or the match is near about 80%. If the match is near about 80%, that means 100% that person will be similar to that. So this type of thing is very, very important. That's why we are applying only machine learning and deep learning here. We are not applying the AI. In the deep learning approaches, the large images or the complex images will be converted itself into a very simplistic feature, which will be very easy for us to classify. That is called as your feature extraction. Later, when it will be applied into some example, you will better understand what is the meaning of feature extraction that I'm writing right now. In short, what we are trying to do is we are trying to extract out the important image data, and also at the same time we are reducing the size of the large images. Suppose you are having an image of 100 pixels, 1000 pixels by 1000 pixels. All right, and those images will be near about these many pixels are there. When you are having these many pixels, it's almost like very huge data. So you need to reduce the size of it. Then only you can get a very good accuracy without losing much of the data. That should be also an approach. So that's why with the images, DL approach is very, very good, because of the phenomena that the DL basically reduces your images, but also at the same time it does not lose any of the data. You don't lose any data in this method, whereas in the top method there is a chance that you will reduce the size of the image, and this will result into losing a lot of data. And as you know, whether it is machine learning or deep learning, they both are dependent upon the data itself. Any other question? Shall we use DL for unsupervised? We can use it for unsupervised as well. But mostly it is used for supervised. But we can do it. Like we can apply it in some other examples where the unsupervised learning approaches are also there. So both categories are there, supervised and unsupervised. Those who don't know about what is supervised and unsupervised, we will be discussing them in few minutes. But in deep learning, we are also having the unsupervised methods as well. Any other queries? Any other questions? All right, so no questions are there. That means we can proceed to the next part now. The next part is all about the various classification of the data, and then we'll check what is the meaning of supervised, unsupervised learning. Let's get back to the PPT. So here are some of the differences between AI and machine learning that you can learn. So here AI stands for artificial intelligence, where intelligence is defined as an acquisition of knowledge. Intelligence is defined as an ability to acquire and apply the knowledge, whereas machine learning approach is defined as the acquisition of knowledge or a skill. The aim is very important. The aim of the AI is to increase the chance of solving the problem for a success. It's all about solving for success. Solving for success. Okay, here it's not about that, it is about increasing the accuracy, and in order to increase the accuracy we are into deep learning. Okay, it does not take care of the successes, it's all about solving and solving for increasing the accuracy and all. It works as a computer program that does a smart work. It is a simple concept. The machine takes data and learn from the data. The goal is to simulate the natural intelligence to solve the complex problems. Okay, there will be a problem and you need to solve it for the success. That's the approach here. Here it is all about maximizing the performance of the machine to solve the task uh, and learn the data as well. The task will be solved depending upon the data. Here in this case, in both the cases, it's all about the AI is about the self decision making ability, just like a human brain can think. Similarly, here, self decision making ability will be there. Whereas in machine learning, it involves in creating self-learning algorithms. Deep learning we have already discussed about. So deep learning is a particular kind of a machine learning algorithm that is inspired by the functionality of brain cells called neuron, which lead to the concept of artificial neural network. One more thing that we have not discussed yet is about the data science or big data analytics. Now, when you say that data science part, data science is like only half of the, only few part is you can say common between deep learning, machine learning, or AI, but mostly your data science is independent as well. How data science is different from your uh, machine learning or AI or deep learning approaches? So data science is about learning the insights of the data. The hidden treasure, we call data as a treasure right now. So to identify what is the hidden insights of it will be the approach of your data science. To extract out the important information out of it, the hidden insights out of it will be the approach of your data science. Okay, in the data science, your machine learning is having subcategories. We will discuss about them. Let's first try to understand the data science in deep. What kind of an approaches you will be doing, or what kind of a problem statement you deal in data science? Data science is all about, okay, in this case, in your data science, use of statistical function is good enough sometimes. To identify hidden insights of the data or parameters of the data. Not always algorithms, machine learning algorithms will be compulsory. Not always deep learning, machine learning, AI algorithms will be compulsory. Okay, that's the approach of your AI, ML, deep learning, data science, etc. Let's have a flow chart of data science. I'll get back to the whiteboard again. Let me switch the screen. Hence, we are into the data science now. Let's see the approaches. Just now I said the data science approach This is mainly in business, solve for the business problems. And get the insights of the data. Solving the business problem and get the insights of the data. That is the approach of your data science. Let's say, what's the flow of data science? First, data science talk about, it includes how to get the raw data. Raw data means data from various sources. Let's say data from the website, data from the Twitter, from social media, social network like Twitter. Let's say you want to check like which tweet is trending today. You require all the tweets, and the approach should be such that your value should be continuously coming in a streaming format. All right. So the various data, raw data, like raw data from various RDBMS like Oracle, etc., or MySQL. Like MySQL or Oracle. We have identified our raw data. The next flow is about extract features. Extract out the important essence of the data by the various approaches like SQL, SQL queries, some packages like pandas, which you will study in future or maybe tomorrow. Pandas, NumPy, etc. These are your Python important packages. The most important thing which makes it different from the machine learning, maybe this could be also part of your machine learning, maybe this could be also your machine learning approaches. But the one thing that makes it entirely different is that it says that here in this case, not always your machine learning algorithms will be required. Even a basic statistical function will be more than enough. Not always it requires the machine learning algorithms. Basic data analysis tools are more than enough just to analyze the data, just to analyze the hidden insights of the data. In order to solve for the given problem, you require, once you have analyzed your data, you will be presenting it. So data presentations, in a visualization form is always treated as good and very easy for the understanding. At least like the people who are from the business domain, they will able to easily understand it if your data is visualized. So the visualization part will be always the key chain in the data uh, data science flow chart. So visualization is important. Next, after visualization, the approach is all about data visualization, then business intelligence, or BI in short, and suggestions for improvement if it demands for it. Let's say you have a given problem statement of what are the key things. Let's say a company is there which is there in a food industry. Who wants to up their sale of food by 50% in next financial year. So let's say in the food industry, we want to increase our sale by 50%. What should be our approaches? Those approaches, we need to analyze it by the data. Then from the various sources you will take, then you will be in the end you can suggest like, okay, these are the from the data we have analyzed it and we come to the conclusion that these are the things that if anyone will do, they will get the good, you will able to reach to the goal of improving your sales by 50% more. All right, so it's all about that, learning the insights of the data and making the decisions. Data science is very, very important for the businesses as they are helping the user to understand that what are the hidden insights of the data and they can analyze it. Next up in the flow is, let me just make my screen full. Okay, now we will be analyzing. We have talked about data and all. Let's talk about the data itself more. Here are some examples. Let's say the self-driving car, which comes under the AI and deep learning. The humanoid robot, it's totally your artificial intelligence. This humanoid robot is Sophia. The Snapchat filter, I hope most of you will be recognizing it. This flower crown selfies. This is also your approach of augmented reality, which is also one of the leading technology right now. AR in short, AR, VR, you might have heard about it. Combined with machine learning, helps us in giving the flower crown selfies. Netflix, the OTT platform, which is available to as a source of entertainment, it's one of the leading source of entertainment, uses the approach of machine learning to recommend you recommend all the users that what kind of a shows the person will like to watch. So the suggestion is really, really very good here. Even the shows which they made, they uses the machine learning approaches a lot. The chatbot, the conversation, the Google conversational messenger, or the Siri example is also one of the one of the things that you can use as an example to your AI. So here are some of the examples. Now they all are dependent upon the data. So why not let's first try to classify the data sets. Your data is divided into majorly two categories. First category is numerical. The second category is about non-numerical. The non-numerical data is also called as qualitative. Qualitative, the second point is about quantitative. Qualitative and quantitative. Qualitative is categorical, quantitative is numerical. Categorical variables have values that can only be placed into the categories such as yes and no, or something like this. Okay, let's say true, false. Okay, person is diabetic or not diabetic. Non-numerical approaches will be there. Those are called as categorical data sets. For example, marital status. There could be 3 stages of marital status: single, married, or divorced. Name of the political party, names only. Color eye, there are also names. We are having the sensors high and low, the proximity sensors that gives you the output in terms of either the sensor will be high or the sensor is low. These are all comes under your qualitative approaches. The qualitative data is classified into 2 sections majorly. One is nominal data set. In the nominal data set, we talks about names only, just names. And the second part is ordinal. In the ordinal data set, we talk about the data when it gives you the sense of order. Like, you can't arrange the gender in an order form, isn't it? But the gender will be there in names. Male and female. So those are just names. Then sense of order, like grades. Grade A is always greater than grade B, which is always greater than grade C. So grades will be an example of an order. Similarly, you can have an example of, let's say, ranks in job. You can't there are some positions in particular office that requires a lot of experiences. You can't be placed as a CEO of a company directly. You will always start from a lower rank and then only you can finish at a higher rank with experiences. Unless and until you are not open Very noisy. Kindly check. Somebody's mic is on. Somebody's mic is on. It's very noisy.
Sir, just a minute. Sindhu Velmugan. Mute your mic.
Ma'am, it's
Sir,
very noisy.
Sindhu Velmugan. Someone was
I guess the participant has muted itself. Yes. All right. Thank you. I was discussing here about the nominal data set. Nominal data sets only talk about the names, like name of a party, name of political parties. These name of the political parties can't be classified into an order form. By the way, again, I'm telling you, this nominal and ordinal are the subset of the categorical data set. So hence, you should not place in the ordinal data set especially about the numerical values. You should be placing up only the non-numerical values because categorical, it is subset to categorical data set. Okay, and categorical data sets are non-numerical. Those are non-numerical always. One more data set is there. One more category is there. It's called as dichotomous. Only two categories. Only and only two categories. Let's say if yes and no is there, only yes and no. Two categories, hence it is dichotomous. True and false. True and false, dichotomous, only two categories. Now this numerical values, which are like variables, have values that represent quantities, called as your quantitative data. They are having discrete and continuous values. Discrete values will be limited in number. This will be limited in number. Let's say number of children. Let's say age in a class. Age of a student in a class will be limited. Let's say the student will be maximum, will start from 17 and will end up at 21. That is a maximum age. All right. Continuous data can be anything. It can be any value between minus infinity to infinity. Discrete value will be very limited in range. Limited in range. This will be like any value. This can be any value. Continuous can be any value here between minus infinity to infinity. All right. So I will just put up a revision here that categorical data sets are your non-numerical data set, which are the examples of the categorical data sets are marital status, which can be categorized as divorced, single, married. Political parties, names of the political party, color of the eye, color of the hair. The sensor is there of a proximity sensor that gives you only 0 and 1, or you can say high and low. grades of the student in A, B, C category, A, B, C, D, E, like this, not like rank 1, rank 2, rank 3. Rank will be an example of discrete, because rank is numerical. Rank in exam will be discrete, but grades in an exam will be part of your categorical data set. Ranks in job, the position you hold in job, or profile in job. Position in job or profiles in job will be part of your data of categorical type. Okay. Now let's talk about, on the basis of the data set, we will be proceeding towards all right. So we are done here with the differences of the data sets, the various data sets that are there available. As you can see, so dichotomous data set is there, nominal data set is there, ordinal data set is there. By the way, your dichotomous data set can be of the part of any of these. Dichotomous can be numerical, dichotomous can be non-numerical. Let's talk about the type of machine learning now. Any questions in this? What is dichotomous is clear. Dichotomous means only two categories, whereas nominal data set and ordinal data set, those are about your names, and ordinal means sense of order. Numerical values can be of two types, discrete or continuous. Okay, so is it done? Any queries, any questions?
Sir, what is reinforcement learning, sir?
Reinforcement learning I will be discussing in just after the type of machine learning. We'll discuss it. In the type of machine learning, we are having three major categories. One is supervised learning, the second one is unsupervised learning, and the third one is reinforcement learning.
Okay, sir.
So the three different approaches are supervised approach, unsupervised approach, and the last one is reinforcement. I don't think so in this section, in this training, we will be discussing anything about the reinforcement. But as far as the definition is concerned, I will definitely discuss about it, that what is exactly your reinforcement learning is. Let's talk about first supervised learning and unsupervised learning. So supervised learning is about, okay, before that, we should know about what is the meaning of what is exactly your supervised learning do. Okay. Then we will go into the subset of supervised learning, which you are seeing in here is basically about the two major categories of your supervised learning, which contains most of your problem statements. Most of your problem statements are categorized under supervised only. There are very few examples that we do in unsupervised learning, but yes, definitely we are having some examples about it as well. Let's talk about the supervised learning examples, problem statements. So when you will say that it is a supervised learning approach, supervised learning is when your input variable X, okay, input data is basically categorized as X, When I started the session, I already said all your inputs will be denoted by your x values. Those are called as features. Now, features are very important input data. Those are not like your all the input data are important. For that, you need to see the problem statement, which is denoted by y, which is your output variable or target variable called as label or class. Label or class that uses an algorithm to learn the mapping function from the input to the output. So it's all about mapping the y and x with the help of the machine learning function. The goal is to approximate the mapping function so well that when you have an input data x, that you can predict the output variable for y for the data. Let's talk about let's say I'm having a problem statement that contains my data set with serial number, name of the participant, name of the student, let's say. This is a data collected from by the university, and this contains the marks detail. So we are having the serial number, the name, the year of the student, or let's say age of the student, its home location, from where this student belongs, name, age, location, hours studied, hours rest, and in the end, it's about the marks. Marks is given by y. Now tell me which has the capability, which looks like more important when it comes to making prediction for the marks. Will it be the serial number? Will it be the hours studied? Will it be the hours rest? Will it be the location of the student? Will it be the age of the student that will be the factor about identifying, about making prediction for the marks of the student? So can you tell me what kind of a thing will be more important here? What will be more important? Is it the serial number? Is it the name? Is it the age? Is it the hours studied? Is it the hours rest? Try to identify logically.
Hours studied and marks.
Marks is like your y value, so don't include y as your features.
Hours studied, sir.
Okay, one will be your hours studied. So let's say x1. Your y is your target, so don't include them as a features. Features will be independent of your y value. Y is different. Y is called as your output. This will be your output, and these are called as your features. So first, let's talk about, can serial number be a feature here? Can serial number be a feature here?
No, sir.
Can name be a feature here?
No, sir.
No. Age?
Yes, sir.
Yes.
Location of the student?
Maybe.
No. Hours studied?
Yes.
Hours
Yes. Yes, sir.
So these are your features identified by x1, x2, and X3. Multiple features, they are called as multivariate. Names, remember these names. Multivariate for multiple features. Multiple features are called as your multivariate data, and on the basis of it, you will be making the predictions. Okay. So this is called as your supervised learning approaches, where your X is also given and the relevant target output is also given. That means your Y is also there, your X is also there. Let's see here the supervised learning. So for supervised learning, in short, you will say if label, the target is called as label. So if label equals to yes, if label equals to yes, it is all about this. It is called as supervised learning. Hence, it is very easy to identify here the label will be not available. That means there will be no as such numerical target. Here you will solve for the given target. Here you will solve for the different problem statement. We'll talk about it afterwards. All right. There are differences like now. We just understood the different types of data, especially about when your data is numerical type. So that is called as your continuous or discrete type. Hence, let's talk about if target Y is continuous. If target Y is continuous, this type of supervised learning is called as regression. If target Y is categorical, it will be called as classification. Supervised learning for classification, this is called as supervised learning for regression. Given by linear, polynomial, and here the classification will be given by KNN, decision trees, logistic regression, naive bias, and support vector machine. So if your target Y is available, they are called as categorical. If your target Y is available, it is called as continuous. So if label equals to yes, it is called as supervised learning and will be categorized as regression as well as classification. If the label is no, it is called as unsupervised learning. In your supervised learning, there are two subcategories. Regression, when your Y target is continuous. For example, here I'm talking about Y as marks, which comes under continuous example. And if Y is grades, those will be called as your categorical. Or discrete. Unsupervised learning. Unsupervised learning is when only have input data X and no corresponding output variable is there. The goal of the unsupervised learning is to model the underlying structure of the distribution in the data in order to learn more about the data. Here it is all about discovering the hidden patterns or the hidden groups. It is all about taking the features and structuring them in, you can say, in a cluster of distribution. The distribution will be done so that we can learn more about the data, and we can discover the interesting features, the interesting hidden patterns about the data. So it's all about utilizing it. Let's see through an example what is exactly your unsupervised learning is. I hope most of you are aware about the COVID-19 scenario. So let's take an example of, this is all about your unsupervised learning. In the unsupervised learning, you will be having only the features. When you will apply into the f of x, it will give you, it will form the cluster. Form the cluster, learn the hidden insights about the data. There will be no target in this. Always remember, there will be no hidden target output here given by y. So how does we apply? Let's say we are having an example of, we collected the data of COVID-19 for 50 districts, or let's say 50 cities, or let's say 30 cities. You have taken the data for the 30 cities, and when it comes to the data, those data for the COVID-19 are classified as number of cases, number of confirmed cases, number of deaths, number of confirmed cases, number of deaths, number of active cases, number of confirmed cases, number of deaths, number of active cases, number of recovered patients. X1, X2, X3, X4. These are your 4 different features. X1, number of confirmed cases, X2, number of deaths, X3, number of active patients, and number of recovered patients are given by X4. Let's take our data and let's try to identify. So the role is to take the data set. Let's say this is your data, okay, which is distributed in a distributed fashion. It is here and here. Each cross that I'm denoting here contains your features. Those features are given by X1. Those features are given by X1, X1, X2, X3, and X4. Okay. Ideally, there are like 4 coordinates here: number of confirmed cases, number of deaths, and number of active patients. What I want to do is I want to apply an approach of unsupervised learning and want to classify them into 3 clusters. Convert them into clusters, 3 clusters, by applying the unsupervised learning algorithm. Convert them into 3 clusters. Let's say those will be denoted by red zone, green zone, and orange zone. So hence what will happen is, depending upon the values of number of confirmed cases, number of deaths, number of active cases, the unsupervised learning will able to classify them into 3 different categories. Here the user need to provide how many clusters you want. The algorithm itself will not able to identify. Number of clusters will be chosen by user. So as I said, there are 3 clusters here. One is red zone cities, the second one is your green zone cities, and the third one is your, let's say, blue zone cities, which is, or let's say, orange zone. For orange zone, I need to change the color. Orange zone cities. What is the benefit? The benefit is about when a new user, new city details you will be feeding, you can classify on the basis of the previously classified or cluster form. This is, let's say, a new city is there. So with the characteristics of number of confirmed cases, number of deaths, number of active cases, and number of recovered patients, it will see that if it is near to this part or near to this part or near to this part, and then we'll identify whether it belongs to whether this new city is a red zone city or it's a green zone city or will be an orange zone city. So like this, your unsupervised learning will able to actually perform classification for the new samples, utilizing or using the previous unsupervised learning algorithm approach, where the number of clusters will be given by the user and it will be applying the algorithms which are given by say unsupervised learning algorithms are available to us. So this is one of the examples that will help you out to understand how exactly your unsupervised learning actually uses this distributed data and convert them into a proper grouping of the data, will be grouping it into a proper format so that you can like identify which all cities belongs to red zone, which all belongs to the orange zone, and what are their key characteristics. All right, class. So this is all about our machine learning. The only thing that is not been discussed is about your reinforcement learning. So let's talk about the reinforcement now. Reinforcement learning is quite different from the other two machine learning approaches. It works on a phenomena of your AI agent based learning first, or simple agent. This agent will act like a baby, and just like baby, when it gets introduced to any new environment, it will try to learn from its mistake. So in a long run process, what it does is it performs actions over the environment. The environment will act like a source of the data, which will give us the reward on correct moves and the state of the environment, like what is the change in the environment has taken place. Change in the environment, which is called as state, and reward is your, these two will be your feedback provided to the agent, and the agent will keep on will improve its decision making ability. This feedback will be stored in the memory. All right. So the approach is very simple. Try to understand it with an example of a, let's say there is a baby and you want to teach that baby how to operate a remote. What you will do? First, what you will do is you will just give it the remote, and as an autonomous agent, the baby will keep on pressing the buttons. So those buttons will basically will be the action. The press of the button will be action. The environment here will be the television, and this is like done on the remote control, and will press the button. That will be the action. The environment will be about your television. Whatever the action that baby will take, it will give us the feedback about the state of the television when it press the, say the goal is to learn volume buttons. So the baby does not know about what is the what exactly, where exactly your volume button is. So it will press all the buttons, and once it succeeded, then only the reward will be given. Reward will be only for success. For failures, there will be no reward. And hence, your reinforcement learning becomes one of the method where the learning mechanism is autonomous. The agent here, which is mostly your AI agent or AI agent, and they will be keep on improving itself. Suppose solving, like especially in the gaming environment, reinforcement learning could be one of the examples. Let's say balancing let's say balancing a particular pole. A pole is there on a moving roller and you want to balance it. So whenever I try to move towards this side, there has to be a feedback that will be provided, which will balance the pole on the moving roller. Or could be one example of your AI based games, like a racing game or etc., this type of thing. So reinforcement learning approaches are the best examples where this will be implemented are the games or wherever the feedback mechanism will be important. The learning will be done mostly by the feedback. For the reward, by the reward will be only provided for the success. For failures, there is nothing, no feedback. That means if if the agent loses the game, that means no reward will be given. Only for the correct actions, the reward will be feeded, and that's how it is also called as your reward-based learning mechanism. Why your AI and machine learning are trending right now? The answer is simple. We are having more and more digital format of the data which is available. Over the course of the time, we have the industries have developed and they have started storing up their in like data over the platforms or the cloud platforms or the social media platforms. Somewhere your data is available on the cloud and hence it is available. All right. So because of the availability of the data, which has increased over past few years, especially last 10 years, if you will see, this AI ML is in the trend. These are not new techniques. For your concern, I will say like your the first AI program was solved during 1943, during that World War scenario. So you can see like this is not a very new technique. It's a very, very old technique. But we were not having the availability of the data. Right now, we are having a lot of data available. Hence, these things are trending, and especially it has been accepted in the businesses as well to make everything autonomous. Okay, so why it is trending? We are having more amount of data. We are having a very good computation resources available. Our algorithms are development ready. The softwares or the tools which are there have a very good performances. We are having the new technologies through which you can real stream your data. You can fetch the data and you can feed them into the algorithms so that it can take the real decision making ability. It has got the cloud computing. It has got the big data environment. It has got the packages that helps not only just R programming, Python programming, Java, C++. In all the leading programming languages, the AI ML are now available. Especially the big data is one of the revolution thing that has been there, where the people like the industry have learned about how to use the huge amount of data in a very easy way. Rest all, I guess we will be discussing it. Maybe it will be done by some other people. And that's how I'll be finishing off my first session. So thank you so much for attending this program. If you have any questions and queries, please go ahead and ask.
So I hope there is no queries from the participants. Thank you, Mr. Amit Mishra, for giving the clear definition of artificial intelligence, machine learning, and deep learning, and its different applications of it. Also, you have given a clear differentiation of supervised learning, unsupervised learning, and reinforcement learning. Thank you.
Thank you, ma'am. And thank you all the dear participants. I hope you have got the clear picture about what is machine learning, what is deep learning, what is data science, and how they are different from each other. Thank you so much.
Okay, dear participants, that afternoon session starts by 2 p.m. That feedback link will be shared in this chat window. You give your feedback through the chat window. Thank you.
All right, participant, you kindly give your feedbacks. I'll take the leave now. Thank you so much, and see you in some next session.